Hey guys, welcome back. This video is going to be about RL series circuit, and we're actually going to do an RL series circuit together. But before I do an RL series circuit or an RLC series circuit, we need to talk about phasors and leading and lagging phasors, because this is always really confusing for students. Okay, so when we're talking about leading phasors and leading currents and lagging currents, we need to understand what that means and how it looks. The first thing I need to talk to you about is, when you're talking about the leading or lagging circuits, you're really always talking about the current. In other words, if I talk about an inductor, I would say that causes things to lag. It causes the current to lag. And the capacitor causes the current to lead. The voltage, right? Lags the voltage, the current lags the voltage, the current leads the voltage. All that means is if I had an inductor and I took a look at the two sine waves, the voltage sine wave, let's draw that here for a second. Okay, so that's E. An inductor always causes the current to lag the voltage, which means if I were to draw the current phasor or the current sine wave on here, it would be sitting here lagging by 90 degrees. Okay, there's the current. Same thing for the capacitor. It causes the current to lead the voltage, which means that if this was the voltage phasor right here, guys, and I took a look at the current phasor for this conductor, the current phasor, too many pens, would look like this. It would be leading the voltage. Okay, so there's current. And when I say lagging, I mean this is time, right guys? So this is time here, and lagging just means it comes later. All right, so the voltage came first, the current comes later. How far later? 90 degrees later if it's an inductor. Same with this one. If this is time and that's the voltage, I would see on a scope, if I were looking at this thing here, that the current was coming beforehand, or it's leading, okay, because time is this way. Current first, voltage later. How much is it leading? 90 degrees. All right, guys? Now, what if I drew those as phasors? What would they look like? Well, I can draw these really in two different ways. Okay, so here's my little phasor world here. And really, I'm going to draw two of them just for fun here, because really it depends on which one I draw where. Okay, so for example, if I drew the voltage phasor on the horizontal line here, guys, let's get a different color here just for fun, blue. I learned from the last couple of videos not to use the pink pen, too hard to see, right? So here's the voltage phasor. Let's just say, just for fun, that I drew it right here. So if that's the voltage phasor and I want to draw the current phasor, the question is, I know it's out of phase by 90 degrees. The question is, does it go up or does it go down? And the answer is it goes down. Here would be the current phasor in this situation, because lagging phasors are always drawn clockwise. And so if this was a clock, the clock's going like this. So a lagging phasor needs to be drawn clockwise from the leading phasor. Now I could, this here basically shows the current lagging the voltage by 90 degrees. The current is drawn clockwise because the current is the one that's lagging. Now, I could also draw it this way. If I decided to draw the current first, guys, and I wanted to draw it so that the current is lagging, okay, I would have to draw the voltage like this. Okay, these two things are exactly the same thing. One shows the voltage on the horizontal line, the current lagging by 90. This one shows the voltage on the vertical line. The current is still clockwise or lagging by 90. Now, the capacitor is the same thing, guys. Okay, so let's draw the two kind of possibilities that I could have here, depending on which phasor I draw first. Let's say I drew the voltage here, okay? If this is the voltage and I want to draw the current, and I need to draw the current leading by 90 degrees, leading phasors are always drawn counterclockwise, and counterclockwise is this way. So there would be the current. That current is shown leading. if I draw the current here, guys, and I want it to be leading the voltage, I would have to draw the voltage here. Okay, that way the current is counterclockwise or leading. Now, how are you going to remember this, guys? Well, less letters, more letters, more letters. Okay, guys? So if you can't remember if lag is counterclockwise or clockwise, think about this. It's got less letters than lead. Clockwise has less letters than counterclockwise, okay? Because you're going to have to keep that stuff straight, okay? If you can't keep it straight, it's going to be confusing and tricky. All right, guys? Now, what I've got here for you is a question that we're going to do together. This is an RLC series circuit. And you can see, as you can imagine, that it's got resistance, inductive reactance, and capacitive reactance all connected in series. Now it's got a couple of questions here. Now we're going to answer those, and maybe we're going to even answer a few extras. Now annoyingly, I've given you, and by the way, this is right out of your homework book, guys. This is Unit 2, Handout 2. It's question number 14. Unit 2, Handout 2. You can go look for it if you want to. You'll see it there. Why are we starting with question number 14? Well, because the first 13 questions on that particular handout are RL series circuits, okay? So if you want to go straight to the RLC series circuits, you go straight to number 14 and you can try it, okay, guys? Now, since these values were given in microfarads and henries, the first thing we have to do is figure out XC and XL, and we'll do them one at a time. XC is 1 over 2 pi FC. So it is 1 over 2 times pi times 60 times 0.00002. Okay? And now I'm really running out of room here, but let's calculate it for a second. Put my calculator right there. 2 times pi times 60 times 0.12342 equals, and then 1 over x equals 132, okay? 132.6 ohms. Okay, guys? XC. XL is 2 pi FL, so it is 2 times pi times 60 times 0.3. Let's try that. 2 times pi times 60 times 0.3. Looks like it's 113. XL is equal to 113.1 ohms. All right, so if I give you farads or henries, the first thing you're going to have to do is figure out how many ohms that is. You know, don't try to calculate this using that 20, trying to, figure out the phasors by using those values. You must use the ohms values. They all have to be in ohms. Okay, guys? Now, that was step one. The very first thing it's going to ask for here is Z, and in order to calculate Z, which is the impedance, it is going to be the phasor sum of these three. And so we're going to draw our little phasor world here, guys, and we're going to compare all the phasors to the current. And the reason we're going to compare them all to the current is because the current is the same for all three. So we're going to compare them to the thing that they all have in common. Now I'm going to draw the resistor first. That's always a good idea. Start with the one that's on the horizontal line. That 50 ohms is going to look like this. R equals 50 ohms. Why is it on the horizontal line, Van Andel? It's on the horizontal line because resistors are always, well, they cause the current to be in phase with the voltage. Okay, so I've drawn that in phase. It doesn't make it lead or lag. It's always in phase. The next phasor that we're going to draw is going to be XL. And it doesn't matter if I draw XL or XC next. It actually doesn't matter no matter which one you draw, in what order you draw them, but traditionally you start with the 50 ohms. Then you do whatever you like. 132.6. Now this is XC. It has to be drawn so that the current is leading. That means it needs to be drawn so that the current is counterclockwise, which means I would have to draw it down here. Okay, that way the current is counterclockwise. Now I'm going to move it tip to tail, so it's going to end up looking something like this. XC is equal to 132.6 ohms. XL, it has to be drawn with the current lagging, so it's going to actually get drawn up. That way the current will be clockwise. Inductors always cause the current to lag, which means they have to have the current clockwise. It's up there. But I'm going to move it tip to tail, and the way it works is it ends up going from here something like this, okay? And this is XL, and it is 113.1 ohms. All right, guys? Now, this video is already over 10 minutes long, so we're going to stop here, and we're going to finish it in the next video. All right, guys?